Alrighty, so today we are talking about infinite series and sigma notation. So what we had done the previous day was finite series. So that meant that basically you had a start term and an end term, and then you wanted to add everything in between there. But there are such things as infinite series that we can find. All right, so I have a little warm up here just so you can see how this is going to work. So what I'd like you to do is maybe just take a moment to pause it and write in your answers, and then we'll come back and talk about what that is. So again, maybe pause it and then give it a little try there. Okay, so you should have noticed that this was a geometric series because it does have a common ratio, and then you wanted to find the sum of the first 6 terms. So you'd plug it into your geometric series formula, and you should have gotten 182 over 243. Okay, if we do this again, we're finding the approximate sum of the first 20 terms. So we find this sum of the first 20 terms. You should get approximately 0.7499 on that answer. Okay, so maybe before you convert that to a fraction, maybe if you notice that this was actually about 0.74897. And so we have 0.74897 for the first 6 terms, and then the first 20 resulted in 0.7499. So if you continued adding more terms, what do you think the sum is going to get closer and closer and closer towards? I mean, going from 6 to 20, there wasn't a whole big difference there, but maybe what you would have noticed is that you would have gotten about 3/4 or 0.75 is where that is headed towards. Okay, so if you did the first 100 terms, you're just going to get closer and closer and closer and closer to that 0.75. Okay, so this is what's called an infinite series, because no matter how much I keep adding, I am just approaching a particular value here. All right, and that's called converging. So it's the difference between convergent or divergent. So if something converges, that means it's going to approach a limit. And what that limit in that previous case was 0.75. It was getting super close to 0.75. Okay, if it's divergent, it's not going to approach a limit. It's just going to continue on and continue on and continue on. There are only certain values, or excuse me, certain series that have convergence, and that is only for infinite geometric series will be convergent. And if it's an infinite geometric series, then you can find a sum. That's the only time you can find the sum of an infinite series. It has to be geometric in order to be able to do this. And when it's able to do that, you can use this formula. S equals A over 1, or excuse me, S equals the first term over 1 minus R. So if we took that previous problem that we just had in the warm-up, my A sub 1 is 1, and I found out my common ratio was a negative 1/3, so you could plug that in, and that should get you 0.75. So you had 1 over 1 minus a negative 1/3, which is 1 over 4/3, which does give you 3/4. So that is going to be our sum, the infinite sum. All right. Again, if you have a common ratio that's greater than 1, it diverges. It will not have a solution. You cannot find an infinite series if it's greater than 1 or if it's not geometric. It has to be geometric and the common ratio has to be less than 1. All right, so looking at this sequence. Okay, so given the sequence 1, 3, 9, 27, would the series converge or diverge? Hopefully you said diverge. It's divergent. All right. It is geometric. It does have a common ratio of 3, but because the common ratio, so our absolute value of that, the common ratio is greater than 1, it's divergent. All right, so will it have a sum? No, it would not have a sum. That's what that next one is. So the sequence of terms keeps increasing, so the sum will never reach a limit. It's just going to get extraordinarily big. All right, so find the sum of the infinite geometric series. So we go through the thing. It does say it's geometric. What makes it geometric? A common ratio. So the common ratio is a negative 6/9 or a negative 2/3. Okay, that fits It is like I said, it's geometric. This absolute value of this is less than 1. Therefore, it does have a sum. So it is just simply so the sum of that is going to be the first term over 1 minus my common ratio, which is negative 2/3. All right, so I end up with 9 over, so that'd be 3/5. And 9 divided by 3/5 is 27/5. So that is my sum. 27/5 is what that's going to approach. Okay, what we're going to deal with now is what's called summation. And this is what summation looks like, is this Greek symbol here. Okay, so when you see that, that means that you are adding terms. So here's how this works. First of all, you will be given a rule. Okay, that just means an equation of sorts. Okay, so a rule for the pattern. It tells you the initial value you're going to start with. And then this tells you what value you're going to end with. So basically what you're doing is finding the sum from the third term up until the 7th term. So write this given series in expanded form. Okay, what that means is that you're showing your work. Okay, because when it comes test time, when it says expanded form, because I will show you how to do this on your calculator, when you're showing expanded form, we want to make sure that you understand what it is that's going on. Not that you can boopity boppity boopity and plug it into your calculator. All right, so this means, again, that we are starting with plugging in a 3. Then we are going to, so that would be the first thing that I'm looking at. Then I would plug in a 4. Then I would plug in a 5. Then I would plug in a 6. And lastly, I would plug in a 7. That's what that means, all right? So we can go ahead and simplify those. Okay, so again, just getting the numbers for that. So we're showing the expansion, and then that means that I would have, basically what we're doing is we're adding 9 plus 13 plus 17 plus 21 plus 25. And that gives us our total of 9 plus 13 plus 17 plus 21 plus 25. All right, so I get 85. All right, so that's the summation of that. That's what that means. All right. Next example is showing how you can type this into your calculator. So we're not gonna, I'm not gonna be mean and make you do an expansion of like 1,000 terms or anything. That's why the calculator is gonna be great, because if it's not arithmetic or geometric, then you're not gonna want to have to find the sum of 100 or 1,000 terms. So it is nice to have the option to use your calculator. We will ask you to show and expand something that's short. This term has 5 terms that you're plugging in. That's nothing big, so you're going to be able to show that. All right, if you have one of the newer calculators, those are the nice colored calculators, then you have a very easy way to do this. Actually, the calculator I have at home right now that I'm holding in my hand is the older calculator, so I'm pretty sure this is how I'm trying to go off my memory here. So the newer calculators, you're going to hit the math key, and then you're going to hit option 0, I believe. And there should be a summation value where you can just plug in exactly those values. So you could plug in x equals 1, x squared, and then 100, and then hit enter, and it will give you the summation for that. So I apologize if that's not how you do it, but there is a way on the calculator, so you just have to be able to find it. All right, now if you have the older calculator like I do, that's not so quick. Okay, but again, we're going to want to be able to do this because it's not arithmetic or geometric, so we can't use the formula to find the series for this. So you're going to want to be able to use the calculator. So you're going to have to hit your second stat key, go over to the math menu, and hit summation. And then you're going to hit your second stats key, go to the ops option, which is the middle, hit sequence. Okay, you need 4 things in there in order for it to be able to find the summation. You're going to tell it the rule. Okay, so that's your rule, x squared. You need to put in a variable. It's always going to be x. You're going to tell it where you're going to start and what number you're going to end with. So it will add all the way from 1 to 100 and squaring each of those terms. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and adding all those values all the way up to 100 squared. And you should get a sum of 338,350. All right. Okay, so now sigma notation is the same thing as summation. Okay, that's that little symbol there. That's your summation. So what you're wanting to do is express this following series using sigma notation. Okay, now for you guys, I'm just going to want you guys to always start with 1. Okay, so when you're writing these, just start with 1. Okay, so we're going to write a rule for this. So looking at this, it is arithmetic, by the way, but it does go up by 4 each term. So our rule is simply just 4x. So again, when you plug in a 1, you do get 4. When you plug in a 2, you do get 8. When you plug in 3, you get 12. Plug in 4, you get 16. So what number is going to go up here is a 4. Okay, now it just happened, again, it should be pretty straightforward if you're using a 1, because you plug in a 1, that's the first term. How many terms do we have? You have 4 terms. Okay. Now, if you want, I mean, you can alternate these numbers, but that's just going to be the quick way to do this. Okay, so what I mean by that is this next example, I didn't start with a 1. Okay, so it looks like this. So write the following series in expanded form, then find the sum. Okay, what does expanded form mean? It means show your work, okay? I know you guys can plug that into your calculator. You need to show me that you know what this means. All right, so expanded form, you're showing that you're plugging in a 0 to get our first term. Then you're going to add that to plugging in a 1. Then you're going to show adding that to plugging in a 2. And then you're going to show plugging in the 3. Okay, so that's expanded form, and then you'll go through and actually add them all up. So we have 2 squared, so that'd be 4 plus 10 plus 18 plus 25 plus 28. All right, and then you can get your solution there. Now, you're more than welcome to use your calculator and check to make sure you didn't make any silly mistakes, that you do get 60. By all means, check your answer. But if you do not show this in your expanded form and you only give me solutions, you're not going to get full credit, okay? All right, so that is it for today. Enjoy your weekend.